we'll look into the first lesson in grade 10 syllabus, the perimeter. The perimeter is the distance around a given two-dimensional object. Simply, the total length of sides of 2D shape. It is the surrounding length of the object. The surrounding length means the outer length. That would be A plus B plus C plus D. So the perimeter is given here. You would have studied the perimeter of rectangle, square and triangle and a circle in previous grades. In this grade 10 syllabus, we'll look into the perimeter of the sector. Before moving into the perimeter of the sector, we'll look into the perimeter of rectangle, square, triangle and circle. So first of all, while looking into the perimeter of the rectangle, you know the opposite sides of a rectangle are equal. So this, if this is A, this would be A. If this is B, this would be B. So the perimeter would be A plus B plus A plus B. That is 2 times length plus breadth. That would be 2A plus B. Let's consider an example. That would be 5, 2. So this would be also 5 and this would be 2. The perimeter would be, I'll mark it as P, 5 plus 2 plus 5 plus 2. That is 2 times the length plus 2 times the breadth. That is equal to 14. Into the perimeter of a square. In a square, all sides are equal. So if this is A, this would be A, this would be A, and this would be A. So the perimeter would be A plus A, that is equal to 4A. So that is the perimeter of a square. Next, the perimeter of a triangle. If this is A and this is B and this is C, so we have to add up these 3. So that would be perimeter is equal to A plus B plus C. For example, if we consider 3, 4 and 5, the perimeter is equal to 3 plus 4 plus 5. That is equal to 12. For an equilateral triangle, all the sides are equal. So that would be A. So the perimeter is 3 times A, that is 3A. So we look into the perimeter of the circle. We don't call it as perimeter, but we call it as circumference. So the circumference is the length around a closed curve. And we know that the circumference over diameter is equal to pi. Circumference over diameter is equal to pi. So we can find the circumference by cross multiplying this diameter with the pi. So that would be circumference is equal to pi into d. If pi is a constant, that would be approximated as 3.14 or 22 over 7 or 22 over 7. So the d diameter, this length, is the straight line that passes from one point of the circle to another point through the center. So in the other case, we can call it as the 2 times the radius. So this would be one radius and this would be the another radius. That is, d is equal to 2 times r. So we can write the circumference as pi d or 2 pi r. As d is equal to 2r, we can write it as pi d or 2 pi r. We'll look into the perimeter of the sector. The shaded part over here inside the circle is the sector. So by definition, the sector is a portion of circle that is enclosed by two radii and an arc. So if we take this shaded region out, this part over here is called the sector. So to find the perimeter of the sector, we need this arc length. We will know the radius of this circle or else the sector. So we have to find out this arc length. So in order to find this arc length, we have to go back to this circle. If this is theta, we can find the arc length. The circumference we found as 2 pi r is for the angle 360. Therefore, for theta angle, we have to find the circumference, the arc length. So that would be theta over 360 into 2 pi r. That is the arc length. So let us say the arc is about half. So then the theta would be 180. So 180 over 360, that would be half the length, half the circumference. So let us consider if the theta to be 90, so then it would be quarter. 90 over 360 is quarter. Quarter times the circumference, that is 1/4 into 2 pi r. As same as that, for unknown value theta, we put the theta over 360 into 2 pi r to be the arc length. So what would be the sector length? Sector length is this r, and the arc length that we found here. So the sector length would be (2r) plus theta over 360 into 2 pi r. So you can write this as pi d and this 2r as also d. We'll look into a small example. So let us consider a circle. So we have to find the sector, that is of 90 degree. This is r and this is r. So the arc length would be 90 degree over 360 degree into 2 pi r. That is 1/4 2 pi r. So in order to find the arc length of this r and 90 degree, we have found this arc length as 1/4 into 2 pi r. So we have to add a sector length. I write it as SL. Pi r by 2, that is here, plus 2r, that is the sector length. This and this arc. Now we look into the section called area. Area is this amount of space the inside of a shape takes up. So the area of a square is A into A, and the area of rectangle is length into breadth, that is A into B. So if we look up for the triangle's area, that would be base into perpendicular height. So the perpendicular height can come in these three formats. So it can come at the edge, inside and outside. So wherever the upper vertex come in, we direct down it to the base as perpendicular. So here the vertex is outside of the base, but we extend this until the base extension of the base meets up to be perpendicular. And then the area would be half into base into perpendicular height. This is h is always perpendicular height. Next we'll look into the area of parallelogram, that is base into perpendicular height. The trapezium is where the area is half into sum of two parallel sides into perpendicular height. Now we'll look into the area of a circle with radius r. So that would be area is equal to pi into r square. So we can write this in terms of diameter also. Diameter is 2 times r. Then r is equal to d by 2. So if we substitute that here, d by 2 whole thing squared, that would be pi d squared by 4. So we can write that as pi r squared or else pi d squared by 4. Next, the area of the semicircle. Semicircle is the half the area of circle. So that would be half into pi r squared. Next is the area of sector of angle theta degree. If we continue drawing this as a circle, this is a part of a circle. This could be quarter, 1/8, 1/12, anything. This is a part of circle. So we can write this as the whole circle would be 360 degree. Among that it is theta. So theta over 360 into the equation of circle, that is pi r squared. Now we'll look into some examples so that you can get more familiar with perimeter and area. So the given question is, the compound figure consists of a rectangle and a semicircle. So we have to find the perimeter and the area of this figure. First of all, this is given as 14 centimeter and this is given as the semicircle. So this should be the diameter. If diameter is 14 centimeter, half of that is the radius, that is 7 centimeter. First, in order to find the perimeter, that is the outer length, this won't come in because perimeter is the outer length. So we have to consider this 21, this 14, and as this is a rectangle, this would be also 21. I mark it as 21 centimeter, 21, and this arc length. So first of all, we'll mark these three. 21 plus 14 plus 21 plus this arc length. We know to find any of the arc length, that is theta over 360 degree into 2 pi r. This is a semicircle, so this would be 180 degree, and as the question suggests, it is semicircle, half the circle, then it would be half, or else 180 over 360, that would be half into 2 pi r. This 2 and this 2 cancels off. Now we know pi is equal to 3.14 or else 22 over 7. So we'll mark here as 22 over 7 into the radius, we found it as 7 centimeter. So we can cut this over here, and the arc length is 22 centimeter. So the perimeter would be these three plus this 22 centimeter. So overall we can write this as, that would be 78 centimeter. as the next question, now we have to find the area. So we have to find the area of this figure. We know the area of rectangle is length into breadth. So we can write as area is equal to 21 into 14 plus this area. That area would be 180 degree over 360 into pi r square. We know the area of a circle is pi r square. So this is half of the circle, that is a semicircle. So 180 over 360. As same as this, the sector would be theta over 360 into pi r square. So now we can get 21 into 14 plus half into pi. So we can write pi as 22 over 7 into the radius is 7. You can cut this. It would be 11. This would be 294 plus this would be 77. So this would be 371 centimeter squared, as the area always comes in square of centimeter. Centimeter or meter or any units, it would be square of it. We look into another example. The figure consists of a rectangle and two sectors of angle theta. This is a rectangle and two sectors of angle theta, two similar sectors. So we have to find the perimeter of this figure and also the area. First of all, to find the perimeter, we have to consider the outer lengths, that is SR and RY and YQ, QP and PX plus XS. So that would comprise of 2 times A and the radius of this sector and this sector, and also this arc length and this arc length. So we'll write down what is needed to find the perimeter. For perimeter, we need to add the PQ and the SR. So, and the next, the radius of the sector, this part and this part, that is QI comma XS, the radius. And next would be this arc length, that is PX and RY. Here the length of the rectangle A and A, that is 2A, and we know the sector is a portion of circle enclosed by 2 radii and arc. 2 radii and arc. So if this is B, if this is given as B, this should be also B. So we'll write it as B. And as is a rectangle, this is B and also B. So to find the perimeter, now we have 2A, this and this, plus this and this, plus 2B, plus this arc length and this arc length. So that would be 2 times the arc length, because these two sectors are similar. 2 into arc length. So that would be 2A plus 2B plus 2 into, the angle is theta. So theta over 360 into 2 pi r. That would be 2 times a plus b plus theta over 360 to 2 pi r. Here the r is b, so that would be now we have to find the area of this figure. To find the area, we have to add these two sector areas and the rectangle area. We can easily find the rectangle area. It is a into b plus, as these are two similar sectors, we can write 2 into theta over 360 into pi r square. So that would be a into b plus 2 into theta over 360 into pi b square. So the area is this rectangle area and two sector areas, this and this. So we have written here clearly that a into b plus 2 into theta over 360 into pi b square.
So this is the first question. So here the diagram shows the shape of a plate used to fix a sports equipment. So now first we have to draw this, we have to copy this diagram. So this is a trapezium and this is a sector, 45-degree sector. So this is P, Q, R, S, T. So then read it. PQST is a trapezium. PQST is a trapezium. Yeah. QRS is a cone shaped with an angle of 45 degree at a QSR. So QRS is a cone shaped with an angle of 45 degree at QSR. PQ is parallel to TS. PQ is parallel to TS. Okay. So vertical distance between a PQ and TS is QS. So PQ, the vertical distance with PQ and TS is QS, right? PQ is 16 centimeter. PQ is 16 centimeter and QS is 14 centimeter. QS is 14 centimeter. So it is parallel to this. So now the first question is, find the area of QRS. So the first question is, find the area of QRS. So here QRS is sector, the radius of the sector is 14 centimeter. We know how to find the area of a sector. So area of QRS equal to 45 over 360 into pi r square. So 45 over 360 into pi is equal to 22 by 7 and the radius is 14 centimeter. It's given here. So 14 centimeter into 14 centimeter. So the answer is 77 centimeter square. And the second question is, if the area of PQST is 196 centimeter square, find the length of TS. Now we have to know how to find the area of PQST. PQST is a trapezium. So area of trapezium is equal to half into the sum of the length of parallel sides. So here parallel sides lengths are PQ plus TS, PQ plus TS into the length of vertical distance between those parallel lines. So vertical distance is equal to QS. So here QS. So they have given the area of trapezium. So area is 196 centimeter squared. It's equal to half into so PQ plus TS. We already know what is the length of PQ. PQ is 16 centimeter plus we have to find the TS, so we take the length of TS as x centimeter into QS. QS is 14 centimeter. So now we have to find the amount of x. So the length of x is 12 centimeter. You can go through this practice and so you can find the length of x. And the third question is find the length of the arc QR. So we know how to find the length of arc in a sector. So length of arc is equal to 45 over 360 into 2 pi r. So 45 over 360 into 2 into 22 by 7 into r is 14 centimeter. So the length of the arc is 11 centimeter. And this is the fourth question. If this plate was remade without changing the area of QRS in the area of the plate while changing PQST into a square, find the perimeter of the whole plate. So when we change the PQST into a square without changing the radius of that sector, the diagram will be like this. Because the radius won't be changed, so the other parts of the square will be same to radius. So radius is 14, we already know. So this is also 14 centimeter. This is also 14 centimeter. This is also 14 centimeter. The radius is 14, so this radius is also will be same to 14 centimeter. As you already know, the arc of the sector is 11 centimeter, so it will be remained as same. Now we have to find the perimeter of the whole diagram. So the whole perimeter of whole plate is the sum of these lengths. So 14 plus 14 plus 14 plus 14 plus 11. So the answer is 67 centimeter.
So we've been given this particular diagram where this is a land and Anula is given this particular portion and Kamala this portion, and these are the entry points into the land.
So the first question that we have been asked is to identify the geometric shapes of the plots of land that both annular and common. So what's the shape of annulus portion? As you can see, it's a triangle. But given that this is a rectangle, we also know that this angle is a right angle. So we can write a right angle triangle. Similarly, we can see Kamala's portion. There are four sides, and two sides are parallel. So we can clearly see that this is a trapezium. The answer for the first is Anula's portion is a triangle, right angle triangle, while Kamala's portion is a trapezium. So moving on to the second question, we have to find the area of Anula's plot. So as we said earlier, the area is a right angle triangle. So what is the equation to find the area of a right angle triangle or any triangle? The area is half into base into perpendicular height, or you can say altitude. So let's substitute. So what is the base here? This particular portion. You know this is 20. The whole thing is 100. That means this is 80 meters. So what's the altitude? This perpendicular, because it's already perpendicular, we don't need to calculate it. We directly know this area, this height is same as 80 meters. This will give you 8 times 80, 6400 divided by 2, 3200. Always remember to put the units. This is meters, so square meters. So for question number 3, we have to find the ratio between the areas of the plots of land that Kamala and Anula are to receive. So this is Kamala first, Anula second. So what is the area? We already know the area of Anula's land. Now we need to find the area of Kamala's land. So let's do that first. So as we said before, the shape of the Kamala's plot is a trapezium. So do you remember the equation for the area of a trapezium? It's similar to the equation for the triangle. Everything is half into sum of the lengths of the two parallel lines. What are the two parallel sides? These two. So the sum of the length of the two parallel sides multiplied by, as similar to the triangle, the altitude or the perpendicular height. It's always better to write this equation, because if there's something wrong in the substitution, maybe you'll get marks for the writing the equation as well. Okay, so what is the sum of the lengths? So what are the two parallel sides? This side and this. You know this is 100 and this is 20. So the sum is 100 plus 20. Altitude, as before, perpendicular height. This is perpendicular. So we know this height is 80 meters. If you simplify, we'll get the answer. 4,800. 4,800 watt square meters. Remember the units. Sorry, I think you could not have seen the part of the. So let me explain again. So we need the Kamala's plot area, which is a trapezium. So the area of trapezium is half into sum of the lengths of the parallel sides multiplied by altitude. Sum of the lengths are 120, which is 120, and the altitude 80. By simplifying, we get the answer 4,800 square meters. Now this is not what they have asked. They have asked is the ratio. The ratio between Kamala's plot and Anula's plot. So the area of Kamala's plot, area of Anula's plot. So we already found both of them. What is this? 4,800 to 3,200. Remember, you can put only these in the same ratio if the units are the same. Meter square, meter square. So this can be put as a ratio, but it can be further simplified. So as you can see, 48 is to 32. You can even further simplify because both are divisible by 4, 12, 8, also 3, 2. This is the final ratio. Remember, they have asked the ratio between common-last plot and unlost plot. So common-last plot comes first, unlost second. 3 is to 2. So the next question they have asked, how can this land be divided into two rectangular plots? But the entry points must be the same, and like the areas should be the same. So the entry points are these two. So these two should remain the same, which means the two rectangles should be, this should be common-last, something like this, common-last portion and unlost portion. But the exact lengths and breadths, how do we find? We already know the area, so using that we can find rectangles. So this would be the form: common-last plot, unlost plot. The entry point should remain the same. So but we don't know this length, right? So for that we can use the information we used earlier, the area. We already know the area of common-last plot. We found it before, that was 4,800 square meters. So this area cannot be changed. So this means we already know this side 100. This side let's take as A. So this area should be equal to 4,800. So 4,800 is equal to this area of this particular triangle. Let's say this side, which means the length into breadth. We already know the length. The length is 100 meters. The breadth, that's what we need to find. Let's take it as A. So we know 4,800 is equal to 100 into A, which means A is equal to 48 meters. So we know this length, 48 meters. If this is 48, we already know the entire thing is 80. So we can find B as well, which is 32. So unlost portion would be 80 minus 48, should be 32 meters. The breadth of unlost. We already know the length is 100 meters. So this is how it can be divided, common-last plot and unlost, when they divided into two rectangular plots with the same particular entry area. So we now know it looks like this. So what we have asked in the next question, is to calculate the radius of the larger circular plot that can be marked in unlost plot. So now this is unlost plot, this particular part. So what would be this radius of the largest circular plot? So if we were to draw a circle in this region, the largest circle would be something that would be stretching from this end to this end of unlost plot. So this is the radius. This is the circle. If this is a circular plot, we are asked to calculate the radius. So this is the diameter of the circle. So the diameter of the largest circular plot would be 32 meters. Now that we know the diameter, we can find the radius. So radius is equal to 32 over 2, which means 16 meters. So that's it. That brings us to the end of the second question. Thank you.